Hello, my lovelies! It's Susanna, and today I want to solve this MIT entrance exam from the year 1869 with you. We have 7 questions, no calculator, so let's start with question number 1. If e equals 8, find the numerical value of the following expression. This is our expression. We have e in here, 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 and here, and we insert 8 for every e and try to evaluate this expression. So let's start. Instead of e, we write an 8. Then we have these braces, the square root of this whole thing here, so of 8 plus 1. Then we have the plus 2. Braces, this plus here, new parentheses. Instead of our e, we write an 8. Then we have the cubed root this time of 8. Parentheses, there is no symbol here, so it is a multiplication symbol, and another square root of 8 minus 4. Okay, let's simplify this. We have the 8 here minus. Inside our braces here, we have the square root of 8 plus 1, so the square root of 9, which equals 3. So we have 3 plus 2 in here, which equals 5. So we have minus 5. Then we have the plus. 8 minus. The cubed root of 8 equals 2, because 2 times 2 times 2 equals 8. 8 minus 2 just equals 6, and then we multiply it by 8 minus 4 equals 4. The square root of 4 is 2. Now, order of operations, so this multiplication first, 6 times 2 equals 12, so we have 8 minus 5 equals 3 plus 12 equals 15, and this is the result of our first question. Number 2. Simplify the following expression by removing the brackets and collecting like terms. Okay, 3a minus these brackets here. So let's start inside these brackets. I write them down like this. And here we have some parentheses. So maybe let's just get rid of these parentheses here first. We have b. Then we just have this plus in front of our parentheses. So we can just leave out the parentheses. We don't have to change anything. We have the plus in front of these parentheses. So it's plus 2a and minus the b. Second parentheses here, this is different because we have a minus in front of our parentheses, so we have to change every sign inside. So it is a minus a and a plus b. Okay, let's simplify the things inside our brackets here. So what do we get here? We start with the b's, so b minus b. Okay, this cancels out, but we have another b here, so the result is 1b. And the a's, it's 2a minus 1a, which equals just 1a. Now let's get rid of these brackets here. So we have the 3a, and now we have to change every sign in here. So minus b and minus a. Let's simplify this. 3a minus 1a just equals 2a, and then we have the minus b, and this is our result. Number 3. Multiply this by this and divide the product by a plus b. So maybe let's write down the expression they want us to create. They say that we shall multiply these two, so we take the first one, write it in parentheses, because we shall multiply this by this expression here. So by a squared minus 2ab minus 3b squared. And then they tell us to divide this product by a plus b. So we divide this whole thing by a plus b. Okay, they could have just said simplify this expression here. We have a product in the numerator, which is good, but we have this sum here in the denominator, so we can write this in parentheses as well. So if we want to cancel some things out, then we have to find a plus b as a factor either in this part of this product here or in this part. So we have to see if we can cancel out a plus b. But we don't know if a plus b is a factor of this part here or of this part here. I think that the second factor here looks better because we have just a squared in here. So here we have 3a squared, which makes it a little bit more difficult. So let's try and take the second factor here. So this thing, and let's see if a plus b is a factor of this expression. So let's see if we can write down this here as a plus b. So this is what we have to find out. We don't know yet, but we want to find a product where we multiply a plus b by something else we still have to find, so that we can write this here as a product of these two things where a plus b is a part of this product, because then we can cancel out these things. How do we find this product now? Well, first of all, we have minus in here, so we probably have a minus in here. This is now just a guess. So we try to find these things and then we see if we were right. So we have a minus in the middle here. Then if we want to create this a squared part here, we have to ask ourselves, what do I have to multiply by a? So a times what equals a squared? This would be a times a, right? Then I have a squared. Okay, this would work. What about the next part here? So if I want to create this part, I would multiply b by this second part to get this thing here. So b times what equals this? I need 3b to get there. So I have b times 3b, which equals this thing here. So I would have this as well. The question is, what about this thing in the middle? We didn't use it at all. Yeah, well, we just hope that it works. So let's see if we multiply these two parentheses, if we get this result. So this is just a guess, but usually it works. So let's multiply every element by every element and see if we get this result here. So we have a times a, which equals a squared. Then a times negative 3b, which equals negative 3ab. Then b times a equals ab, if I switch them. And then b times this thing here equals negative 3b squared. Let's simplify this. We have a squared. Then negative 3 of these plus 1 of these equals negative 2 of these green things. And then the negative 3b squared. Can you see it? That this is exactly this. So these sides are the same. So instead of this thing here, instead of this, we can just take what we just found, write it like this, yeah, just without this thing here. And now we have a product, and now we can cancel things out. So we can cancel this and this. And the only thing we have to do now is multiply these parentheses by these parentheses, and then we get our result. It's enough work to do, but let's start by multiplying every element of our first parentheses by every element of our second. So we take 3a squared and multiply it by this and by this. So we have 3a squared times a, which equals 3a cubed, and 3a squared times negative 3b, so we have negative 3 times 3 equals 9, and a squared and b equals a squared and b. Next element, so this is multiplied by every element as well. So we get ab times a equals a squared b, and ab times this is going to be negative. The number, we only have a 3, and then we have a and b times b equals b squared. And then the last thing, everything is going to be multiplied here. So negative is the thing, then b squared times a is ab squared if I switch these, and then negative times negative is going to be positive, b squared times 3b, so 3 and then b cubed. Let's try to simplify this. 3a cubed, there is no 3a cubed or a cubed in here, so we only have 3 of these a cubed. Then a squared b is here and here, so negative 9 plus 1 of these equals negative 8 of these expressions. Then ab squared is here and here, so negative 3 of them minus 1 of them equals negative 4 of these orange expressions, and then we have the 3b cubed, and this is all we can do. Number 4. Reduce the following fraction to its lowest terms. Okay, we shall just reduce this fraction. We have a sum in the numerator and a difference in the denominator, so we are not allowed to just cancel things out. So this x to the power of 6 and this, we are not allowed to cancel this out, because this would only be okay if we had a multiplication here and here. So this is not the way to go, so let's find another way how to reduce this fraction. We need products. So we need a product in the numerator and we need a product in the denominator to be able to cancel things out. How do we get products? Well, by factoring things out, usually. So let's see if we can factor out something here. We have x to the power of 6 here, and there is an x to the power of 3 in here, so we can factor out x to the power of 3. What is left in the parentheses? We have our plus. Okay. In the first part, if we factor out x to the power of 3, we have 3 of these x's still in here, so x to the power of 3. And if we factor out this green thing here, we have a squared and y left in here. What about the denominator? I would love to to factor things out as well, but the problem is that x to the power of 6 is in here, but here is no x in here, so we can't just factor out something. We have to find a different way to write this as a product, and if you have a difference of two parts, so something minus something, always check if this could be a difference of squares. So something like a squared minus b squared. Difference of squares, because there is a form how to write this as a product, and it looks like a minus b times a plus b. And I would love to write this denominator here as such a product, but I'm only allowed to do that if this here is really a difference of squares, because right now I can't really see it. I want to have it in the form a squared minus b squared, so something squared minus something else squared. So let's see if we can write this like this. So x to the power of 6, I can write it as x to the power of 3 first and then square it. This is the same because 2 times 3 equals 6, so I have my square here. Then I have the minus, and I want to do the same with this part. So a to the power of 4, I can write it as a squared and then square it again. So I have 2 times 2 equals 4. And then I have my y squared. So I have this squared part and this squared part, but I only want to have one squared. So I write this in parentheses, take my square here, and in my parentheses, I take the first part, so a squared, and multiply it by y. Like this, if I compare it, I have a squared squared, which equals a to the power of 4, and y squared, which is this part here. Okay, I have my difference of squares, so now I leave the numerator as it is. It looks good. I have my product there. I don't have to change anything, but my denominator, I want to write it as this product here. So I write it in two parentheses that are multiplied. In one parenthesis, I write a minus, in the other a plus, and then if I have a squared, I only use the a in my parentheses. So I have this here squared. I only use this part here for my parentheses. So I write it down here. And the a is here in the second again. So the first part here again. Then I have the minus, and then I just take my b, not the squared, just the b goes here and here. So I take this thing here, the a squared y, and put it in here and in here. I wrote this down on the next page again, and now we have products and things that we can cancel out because this is the same as this. So we can cancel it out, and the only thing that is left is x cubed in my numerator, and this part here in my denominator, and this is all I can do, and I go to number 5. Simplify. Yeah, okay, there is a lot going on. We have this part here, and we shall divide it by this part here. Here we have to add these two fractions. Here we have to subtract these two fractions. So maybe we first take care of this first part here and really add these two fractions. So we have this first fraction plus this second fraction. And then we take care of this part later. So first these two. How can we add fractions? Well, we need the same denominator. So right now it is a minus b, here it is a plus b. They are not the same yet, so we have to find a common denominator. We always find a common denominator by just multiplying these two denominators. So we can take a minus b and just multiply it by a plus b, and this is a common denominator. The same here, we take our a minus b and then our a plus b here. Okay, we have a common denominator now, but now we have to rename the fractions because we changed the first one, right? We had a minus b here, but we multiplied by this part here, so we have to multiply the numerator by this as well. We had a plus b, now we multiply it by a plus b, so we get a plus b squared. And the same here, we had a plus b, but we multiplied by a minus b, so we have to multiply the numerator as well by a minus b. There was already an a minus b in here, so now with the second one, we get an a minus b squared. Let's add these two fractions now, because they have the same denominator. How do we do this? We take one denominator, so I erase this. I don't want to write it down again. So we make one big fraction here. We take one of these denominators as a common denominator and add the numerators. Okay, this is the result of this addition here. Then we divide this, and the same with these two here. We want to subtract them, so we have this first fraction. We want to subtract it from the other one. We have to write these in parentheses because we have this division symbol here. So a common denominator would be, well, we already have done it, so let's do it again. We multiply the denominators to get a common denominator for here and for here as well. And then we rename the fractions. We had a minus b here, so we have to multiply by a plus b. There was an a plus b already in here, so we get a plus b squared in our numerator. And the same here, we had an a plus b, so we multiplied by this, so the same in the numerator, so we get an a minus b squared. We subtract these two fractions. I don't want to write them down again, so let's just subtract them, make it a one big fraction, erase one of these denominators and the parentheses as well. So we take this as our common denominator, and this is the result. Now we have a fraction divided by another fraction. We can do this by multiplying by its reciprocal. So instead of the division symbol, we write a multiplication symbol, and then we have to switch these two here. This goes down, this goes on top. So we have this now. Now we have a multiplication. Here is also multiplication, and here as well. So we are allowed to cancel things out. Not from here, but here where the multiplications are. So we are allowed to cancel out the a minus b here and the a plus b here. So the only thing that is left in the numerator is just this part here. So just the a plus b squared plus the a minus b squared. And in the denominator, just this part here. So it looks pretty similar actually. It's also a plus b squared, but then a minus a minus b squared. I wrote this down on the next page again. And now let's just get rid of all the parentheses. So we have a plus b squared here, which is a plus b multiplied by itself, and the result of this multiplication is a times a equals a squared, a times b equals ab, then we have b times a equals ab as well, and b times b is b squared. If we simplify this, we have a squared. AB plus AB equals 2AB, and then the plus B squared. So this is the result of our first parentheses here. It's A squared plus 2AB plus B squared. Then we have the plus. And now, very similar, just with a minus. So let's replace the plus here by a minus, and let's see what happens with all these things here. So we have a times a equals a squared. A times minus b is minus ab. Minus b times a is minus ab. And negative b times negative b is going to be positive. So we have a squared minus ab is minus 2ab, and plus the b squared. So it's similar, but not the same. It is just a negative 2ab here, but then we have the plus b squared. The same here. So it is the same as this first thing. So we just write down this again. We don't have to find it again. And then this time we have a minus, so we write down the minus, but then the result has to be in parentheses. So this part here is this what we had here, so we have to write it in parentheses and then have to get rid of these parentheses on the next page. But let's do this first. So we have this minus here, which means that every sign switches. So if we want to get rid of the parentheses, we are allowed to do that, but we have to change all the signs. So it's a negative a squared, then it's going to be positive, and we have to switch this sign to a minus. Okay, let's simplify this thing. A squared plus a squared equals 2a squared. 2ab minus 2ab cancels out. Nice. B squared plus b squared equals 2b squared. Then here, a squared minus a squared cancels out. 2ab plus 2ab is 4ab, and b squared minus b squared cancels out, and that's it? No, it's not. Not yet. We have to see if we can cancel things out here, not from the variables we have here, but from the numbers. Can you see that the 2 is in here everywhere? So we can factor out the 2 here out of this sum. So what is left in here? If we factor out the green 2, we only have a squared in here, then the 2 at the plus. And if we factor out this 2, we have the b squared in here. And we have the 4ab here. And now let's cancel the 2 out. So 2 divided by 2 equals 1. 4 divided by 2 equals 2. And now we get our result, which is just what we have here, the a squared plus b squared, and then we divide it by 2ab. And there is nothing else we can cancel out, nothing more to reduce. This is our result. Number 6, solve this equation here. Okay, we can do that. We have fractions in here. But if we take a look at the denominators, these are only numbers. So if we want to get rid of the fractions, we just have to find a common denominator and multiply the entire equation by this common denominator. So let's search for a number that is divisible by 2, divisible by 8, and also divisible by 16. We can take the 16. That works. So let's take the 16 and multiply the entire left side by 16, and the same on the other side, also multiply by 16. Here we have to multiply everything in our parentheses by 16, so we get 16 multiplied by this first fraction here. Then we have the minus, and we have to take the 16 and multiply it by this second fraction as well. And on the other side, we can cancel out the 16 already. So the only thing that is left is the part of the numerator. Okay, let's simplify here. 16 divided by 2 equals 8. So we only have to multiply the 8 by this numerator here. Let's do it. 8 times 3x equals 24x, and 8 times negative 4 equals negative 32. Then here we have 16 divided by 8 equals 2, so we have to multiply the negative 2 by this numerator. So negative 2 times 6x equals negative 12x, and negative 2 times negative 5 equals plus 10. And on the other side, we have our 3x minus 1. Let's simplify it a little bit. We have 24x minus 12x, which equals 12x, and negative 32 plus 10 equals negative 22, and on the other side 3x minus 1. I wrote this down on the next page again, and we still solve for x. We have x in here and x in here, so let's take the 3x and put it on the left side by subtracting 3x on both sides. Then we get 12x minus 3x equals 9x minus the 22. On the other side, this cancels out and only the negative 1 is left. Then let's bring the negative 22 on the right side by adding it on both sides so that we get 9x. These two cancel out, equals negative 1 plus 22 equals 21. To solve for x, we have to get rid of the 9, so we divide both sides by 9. This cancels out, only our x is left. We have a result of 21 over 9, but we can reduce this fraction because both numbers are divisible by 3. So let's do this. So 21 divided by 3 equals 7, and 9 divided by 3 equals 3. So we have a result of 7 over 3. And this is the solution of our equation. And we can take a look at the last question. Solve. This system of equations this time, we have 2 equations and 2 variables here as well. We can use elimination to solve this system of equations, so we can take a look at our x's in both equations. We have 7x here and 4x here, but I want to have the same number of x's in both equations. So I have to multiply this equation by this number, and I have to multiply this equation by this number. So I get the same amount of x's. So let's do this. We multiply this equation by 4, so times 4 on this side and times 4 on this side. And this equation, we take it and multiply it by this number, so by 7, and also on the other side by 7. So we get 4 times 7x equals 28x. 4 times negative 5 is negative 20y. And on the other side, 24 times 4 equals 96. Second equation, 7 times 4x equals 28x. 7 times negative 3 equals negative 21y. And on the other side, 11 times 7 equals 77. Okay, I have my system of equations now. I have the same amount of x's in both equations, so now I can just subtract these 2 equations and get rid of my x, because 28x minus 28x cancels out. Here I have negative 20y. Let's write it down what happens here. Negative 20y minus negative 21y. So I have negative gets positive. So I have 21y minus 20y is just 1y. And on the other side, 96 minus 77 equals 19. So I've already found my value for my y. And to be able to find my value for my x, I just insert the y in one of these equations, but I want the original ones. So I want to insert y here. So I have 4x minus 3 times 19, which equals 57. On the other side, I have my 11. And now I just solve this equation for x. By bringing this on the other side, by adding the 57 on both sides, then I have my 4x here. This cancels out. On the other side, I have 68. Now I want to get rid of the 4, so I divide both sides by 4. I have my x here, and 68 over 4 equals 17. And so I found my x as well and also solved this last question. I am so curious how you liked this entrance exam. Please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!